In this video, we're going to be looking at the time-based simulation modes inside of Fulcrum One. Let's dive right into the software to see how those work. So in this project file, I already have a loudspeaker layout and a room model imported. And to switch to any of our time-based simulation modes, we're going to be in our mapping tab, and we're just going to go up to the top right-hand corner here where we see our current mode. We're going to select this from the dropdown, and we're going to switch over to our first one, which is arrival earliest. Now, the way that earliest arrival works is that it shows on the map what the very first source arrival is at any given location. It does that using a threshold parameter that we define at the top here shown. And this is at 10 dB by default, but you can change it easily by clicking on it and setting any value you'd like. Now, how that works is that we take all the arrivals received at each location and we reject any arrivals that are basically under that 10 dB threshold from the maximum level source arrived at that location. So that rejects out sources that are quieter that we may not want to look at on the map. But as we orbit around here, we can see, and in this project file, I have not set any delay timing yet, but I have my 2 front arrays, and then I also have a set of 4 delay speakers here. And as we hover over this map, we can see the milliseconds of the time arrivals. And as we get back to the back here, then it jumps back down. Let's go ahead and open up our probes tray so we can visualize the echogram view that comes with the time-based simulation modes. As you can see in the back of the room here, I have a probe labeled back, and that's the green one here. And so as I hover around, I can see on this echogram each arrival from each loudspeaker in the design. So our very first arrival is at 27.2 milliseconds, and that comes from delay number 2. It also shows us the level that it got received at. As I hover through, I can see that all the delays are coming first, and then here's the main arrays. And then you can also see that the house right and house left subarray are coming in. However, what's happening with this threshold is on the map, those subs will actually get rejected because they're below the threshold. But let's go ahead and select our delays group here. And I'm going to roll the delay timing up so that you can see what happens on the map and in the echogram. As I do that, the map is live updating, and so is the echogram to show us how those arrival times are shifting. So we're delaying those delay ring speakers back in time, and we can see that shift happening here. As we get them closer to that first array, we can now see that the map is mostly smooth. So we have our very first arrival up here, and as we proceed back, it continuously gets later in time. Now, another way to do this, let's reset that back to 0. And let's look at the echogram a little further here. What I can do is I can actually go and click on one of these arrivals like the house left array, and that drops in a marker here across all the probes, which allows me to timeline across different probes. And then when I hover over the first arrival, I get a delta there as that third property that you see. And so that's saying negative 65.3 milliseconds. So I can actually come in here and type in 65.3, and that sets the delay dead on right there. So that's just another way of setting your delay times, which is what the arrival earliest is great for. Let's dive into the next time-based mode, which is arrival spread. So as I jump to arrival spread here, the echogram stays. It's still showing the same information. What arrival spread does is takes similar data from the arrival earliest, and it basically compares the min and the max between what's received at each location, right? So the very first arrival and the very last arrival, that's within that threshold. Again, we still get that threshold parameter up here. So if we had some quieter speakers arriving way later, but they were under that threshold, they get rejected. So we're literally seeing the sources that are contributing to this at any given point that matter. And again, that threshold is editable, so that if you need to open it up or tighten it up, you can do that. But as we see here, we're seeing up in the top of our chart a little bit of essentially temporal smearing happening on this map. So this is a great tool to use alongside the arrival earliest, especially if you're dealing with larger venues where you have sources coming from multiple directions. That's going to really assist with basically identifying those echo-prone and comb filtering prone areas, basically so that you can get a better, tighter system temporal response. As far as the arrival earliest, that's going to be the mode that you want to use to set your delay times, ensure that you're time aligning your whole system, and that your front to back imaging is set correctly so that localization's happening the way you'd like it. So that's a brief overview of our two time-based simulation modes inside of Fulcrum One. If you'd like more information, feel free to check out our documentation and our support site at support.fulcrum-acoustic.com.